So far we have learned quite a lot from the make command. Let me summarize very quickly for you. So we learned about for the implementation, as soon as we are done with it, we actually follow test-driven development to write a test case about it. And then for make being a command, we also try to declare that under the create clause, so it also can be used as a constructor. And then we really compare in detail what does it really mean when you use that as a constructor, and what does it really mean when you use it as a command. And then we also show you how you can set the breakpoints and launch the debugger. So I think this part here, especially about breakpoints and debugger, will be very beneficial for your career later, especially when you actually work as a software engineer. Whenever you want to do debugging, you don't really just want to print out to the console. Instead, you want to be able to work within your debugger framework, depending on what your language is. That's something I like to emphasize again. Let's do more developments for this particular make command. As I said before, we simply dive into the implementation just to show you, the command versus constructor. But in principle, we should start with the so-called specification of the routine, namely its pre and post conditions. So that's what we will consider right now. Before we consider the preconditions for the make, which is really about input constraints, what should be the constraint imposed upon the input values for the make, so that it can really forbid certain illegal values for the input. But what do we really mean by illegal? In this particular case, make is not just a command, but also is actually going to be a constructor. So let's see what's going to happen here. So the best way to illustrate this is, let's write a test to illustrate my point. So let me go to our test birthday class over here. Let me just add another test, okay? Just another Boolean test case. Okay, over here, a test query. So hopefully now we have seen already a good number of Boolean test queries. So you should be familiar with it already. So let's say T, the common prefix, and then let's say creates invalid birthday. Okay. I'm gonna try. I'll try to create an invalid birthday. Invalid in the sense that it's going to violate the class invariants, right? Remember the three class invariants we have: valid day, valid month, and also valid combination. Invalid birthday, and then no parameter, Boolean over here. And then local, we're gonna manipulate a local variable, let's say BD, birthday. And then always remember to put the comments. Okay, control space for the code completion, just for your information. And then, so it's going to be, let me just copy and paste, because you don't want to make any typo over here. Okay, you want to be verbatim. Okay, paste that and colon, and now just give some informal description, right? Informative description. So create an invalid instance of birthday. Okay. So now, there are many ways to actually create an invalid birthday. For example, I can make maybe the month to be invalid, for example, 13. I can also make the day to be invalid, for example, -1. Or I can make the combination to be invalid. For example, let's say October is not a good example. Let's say November 31st, right? So that's not a valid combination. Okay, so now let's see how we can do it. Let me just choose invalid combination, right? Just for as an example. So if I say create, we know how to do creation. So let's say create BD, dynamic type is also birthday, so we don't have to put it in the curly brackets. It's already explained. Okay, so now let's say November, right? November, there's only 30 days, but I'm going to put 31. So you can see 11 itself alone is actually a valid month. And also 31 itself alone is actually a valid day, but it's an invalid combination. Okay, so what do we expect to happen when we run the workbench system? Are we still going to see a green bar, or are we going to see a red bar because there might be some contract violation? Let's think about it, and let's try to experiment with it. So now under run, so let me say run workbench system. We'll still get a green bar. However, the test that we just created is about creating an invalid birthday, but the test is not in the report. What is that? So I did this intentionally because it's a common mistake. I simply, or you might simply just have forgotten to include it in over here as a Boolean test case. Please don't forget. If you didn't do it, it wouldn't be included for execution in the test cases. So what I would do is I'm going to say add Boolean case over here. and then I would say agent t, and then creates invalid birthday. Okay, just make sure you include it in the test case execution, and then make sure you compile, and then I'm going to run the workbench system again. And now things make more sense, because now, first of all, this particular Boolean test query is not included in the report. And what we got is a class invariant violation. Okay, as you can see in the HTML test report, it only tells you there's a class invariant violation, but it doesn't tell you, for example, which class is that. But of course, so far we only got birthday, so most likely it's a birthday class invariant. But imagine that if you have a big system with so many classes, how would you know which class invariant is being violated, right? And number two, even if you know which class it is being violated for its invariants, which invariant exactly, right? For example, if you go back to the birthday class, for example, you can see even if we know it is the class invariant for the birthday class that's being violated, but which one? It could be the valid month, it could be the valid day, and it could be the valid combination. So which one? So the HTML test report is quite limited in terms of its information, but it has its biggest value is to tell either it's green or red. If it's all green, you don't need to explore any further. But if it's red, you have to explore every failed test by using debugger, right? That's why you have to use either run or run workbench system seamlessly, whenever, whichever one is applicable for your purpose. So now in this case, we would like to do a little bit of debugging and to explore what's going on over there. So that's why rather than running workbench system again, we're going to just say run. So let me now switch back to iFood Studio, and then I will hit on run. So what do we expect to see? We should really see a stack trace that will lead to the class invariant violation. But let's see if that's really the case. So if I hit on run over here, and then somehow we encounter something else earlier. Okay, but it's not too surprising because you can see where we are pausing right now is actually the previous breakpoint we set from this particular test case over here, right? So that's why, and the test case we really want to see, which is creating the invalid birthday, actually comes after this particular one. So hopefully you can see, because it's sequential execution. It's a very common scenario you might run into. So every time, once you finish the previous debugging session, if you believe you don't really need those breakpoints anymore, in order not to really cause any interruption for later debugging session like the current one. So what you can do is you can remove all the previous breakpoints. That's what you can do. To do it, you can either, if you have a very small number of breakpoints, you can simply delete it by clicking on them manually. That's what you can do. Otherwise, you can simply see there is a button here which is called remove all the breakpoint. Why don't we do that? If I do that over here and say yes, okay, remove all of them, and to start from scratch, let me just stop the session here, and then I will launch again, okay, by saying running. Okay, so I would say run over here. So now we should really get to the point that we got an invariant violation, right? You can see the stack trace over here is rather large, but we can only focus on the last few items that make sense to us. For example, you can see from here, the make. So that means we are actually trying to execute the implementation for the make. And after that, it's around here. You can see the yellow arrow over here. That's the flow of execution. That's where things get interrupted or suspended. Okay, so what's the next item? Actually, I should start from here. You can see from this particular test over here, right? Okay, you can see this is where the stack trace is. So you can see we were trying to create an invalid birthday over here. So that's where the execution flow is. It got interrupted, and then because it's actually calling the make over here. And then when we get to the make over here, so that's another activation record, right? That's what we learned previously in the course. And then for the make, after executing the implementation, we are basically checking invariants, and then that's why it got interrupted again, suspended. And then when we got to the invariant, you can see underscore invariant is telling us when it was trying to check invariant, there was some violation. And remember, in the HTML report, it only tells us it was a class invariant violation. However, if we see the stack trace, it tells us exactly which one has been violated. You can see it's valid combination, this particular one that's been violated for the current month and day value. You can see from the objects view over here. Let me show you. You can see from the objects view, let me just make it a little bit bigger here, the panel. Okay, so you can see the day is actually 31 and the month is actually 11, right? The combination is actually wrong. So that's exactly how we can see the class invariance. Okay, so the point is, use the HTML report to summarize if there's anything that's failing. However, if you want to see a particular violation to see exactly how it happened, you have to maybe set a breakpoints and then you have to hit on run to actually see the stack trace. That's something you want to take away. Okay, let me stop this. We have seen that already. So now we know that the invariant actually violation happened is actually pretty bad. So that means we allowed the client to actually, or the caller to pass invalid combination of the month and day. We should not have allowed this to happen. So that means the client should be held more responsibility on passing the valid inputs. So that means we should add more precondition in this case, so that the client's numbers would not cause the creation of some invalid birthday objects. That's what we like to do. Okay, so let's go back to the birthday class over here, and the make over here is also, we know that potentially it can be used as a constructor because it's listed under the creates. So what we want to do now is we want to say require here. Okay, so what should be the precondition for this make? Okay, it should be that it should forbid input values that will cause the invariance to fail. Okay, or you can say that will cause an invalid instance to be created, i.e. the invariance will fail, right? Okay, it's only for command that will also be used for as a constructor, but I'll just say in general, whenever you want to define precondition for a command or query, think about what should be the constraint we want to impose on the inputs or the clients. So now, in order to do it, we just want to make sure those input values like M for month and D for day should really satisfy the invariance already, because they should be the valid combination and M should be valid and D should be valid. So what I will do is I'll simply go to the invariant section over here. I'll do some copy and paste. Okay, let me simply copy this part here, and then we have to do some systematic replacement, but we'll do that together. So let me go back to the require over here, and then I will simply just paste first. And let me fix the indentation here. So each tag precondition should be indented within the require. Okay, it looks nicer. Okay, and then we don't need these comments anymore. So let me just remove it, and then let's indent this inside. And also we don't need this alternative version here. Let's delete it, and then we're going to indent this as well. Indent this, indent this, indent this, indent this. Okay. Of course, it wouldn't compile because actually it will compile. If I say compile over here, because month is really referring to the attribute month over here, and the day is really referring to the day attribute over here. However, this precondition here wouldn't make any logical sense, because think about what's happening here. If we are trying to call the make over here in the context of some creation procedure, at this point, the month and day has not been set to 11 and 31 yet. So what would their values be? Well, simply by default, simply in this case, integer would just be 0 and 0. Of course, you will violate this precondition always. So that's not the way to go, right? So what we really meant to say is the input value over here should be valid, M and D. So we should do a systematic replacement of month by M and day by D. Okay, so M here, and also D here, and also D here, M here, M here, and also D here, D here. It's a bit tedious, but we gotta do it. And then that'll be okay, D here, and also M here. I believe I've done all of them. So now I can just recompile again, Okay, now everything's good. So now, let's say I want to relaunch the workbench system, right? Let's say I don't want to debug just yet. So what would you expect, a green bar or red bar? Somehow you can think about we should not see a green bar because somehow the problem is still there, right? Because we're still having some clients over here who's actually trying to create an invalid instance over here, right? So now what we want to do is, let's say run and run workbench system, right? I want to see the report. If I do that, but now you can see it's still a red bar, but in some way the matter has improved a bit. The situation has been improved because now rather than having a class invariance violation, which we showed previously, now we have a precondition violation. In some way, this is good because let me tell you why it is good. However, even though getting a red bar is not good, we're going to fix that in a moment. Because we know that there might be some malicious caller or clients who might just give us some invalid combination, for example, of the month and day. In which case, we want the supplier not to be worried about executing this particular implementation so that you will create some invalid objects over there. We want to say, even before we try to create the objects, even before that, if the clients violates any of the constraint over here, violation will actually happen. As we learned from the lecture, that means one side is to be blamed. In this case, the clients. Okay. So that means over here, having this particular, let me document it for you. Okay. So now, the input values over here, 11 and 31, is going to cause a precondition violation. And this is going to preventing the implementation of make from being called, right? So that means it's not going to call that. So this is actually a good thing. So let me just compile again. So everything is still fine. I just want to explain to you, in some way, having a precondition as expected is actually good. Okay. Let me just say one more thing. Even though a precondition violation happens in this case. Okay, sorry, my keyboard is getting a little bit crazy here. Even though a precondition violation happens in this case, it is expected and properly protects the supplier. Okay, just want to make a comment. So now, since we know that it's kind of the precondition violation happens as expected, so now we shouldn't get a red bar. Okay, that's my point, right? We only get a red bar when something goes wrong. But here, having a precondition violation in response to 11 and 31 is actually a good response. So it shouldn't be considered as a failure for the test. So this is a very good insight. Let me just write it down again. So I think it's really good to clarify. Otherwise, you wouldn't know why we just need to write another category of test cases. Boolean test query would not be suitable for this case. Remember, what does it really mean when a Boolean test query actually passes? It's when the last value for the result is actually true. If it's either false or when any violation in this case, right? If any violation happens, either it's expected or not, it's going to be considered as a failure. Let me write it down so it'll be very precise. Boolean test query will not be suitable for this case because it fails either because result is false, right? That's when the expected value is not the case, right? Or when fails either because result is false or when some violation occurs. regardless of it being expected or not. Okay, so now what's the conclusion? We need to write another kind of test in which we expect a particular tag. Okay, so which means we have a tag name to specify to tell the IFO runtime exactly which counter violation should really occur. A particular tag violation should occur. Okay, before I show you how to do it, it's actually quite easy to do it, but let me just show you one more thing. So at the moment, we know that we have precondition violation, but can we just see the stack trace very quickly, just to as a completeness? Since we previously saw the stack trace for class invariant violation, let's now see the stack trace for precondition violation quickly. So if I say run over here, so now I should see the stack trace. Okay, you can see the stack trace. Okay, so this is the second item here. We were trying to call this particular make over here, and now because the make has been amended with its precondition, so now even before the implementation of make is actually executed, so now we actually, you know what, it might be nice to actually show you exactly how this happened. So I would suggest the following. It's another debugging scenario. Hopefully you can also learn from this, because we know that somehow this when we were trying to call this particular make, something went wrong. We can see the yellow arrow over here. That means the flow got interrupted over here. So what we can do is we can simply click, and you can see the red circle there. So I just put a breakpoint around this, and then I'm going to rerun the session. So now next time it's going to pause exactly over here, right before the violation occurred, and then I'll step into this particular make and see exactly how that occurred. Okay, so this will be good practice for you to as well. Okay, I already put a breakpoint. So now I'm gonna stop the process over here, and I'm gonna say yes. Okay, so now let me run it again. So now this time I'm gonna pause at that particular point before the violation occurs. Okay, so now I'm pausing over here right before I actually call this particular make over here. So now in order to see how the precondition violation occurred, I'm going to say step into, right? We talked about step into previously. You want to step into a particular routine call. So I say step into. So now you can see now, I'm now switching the context from test example into class birthday, right? So now you can see the make. It does have the various precondition over here. So now you can see the parameter M is 11 and D is 31. So M is 11, 11 is in between 1 and 12. So this is okay. So now if I say one step at a time, so now I pass the very first precondition check, right? If you like, you can also simply select this particular expression here, Control C, and then Control V to paste it in the expression over here. And then you simply tell you that's true. So you can also evaluate just to see yourself, right? And I can also try to predict, should this be true or false, right? I Control C to copy it, and also Control V, I put it here, it's also going to be true, because 31 over here is in between 1 and 31 inclusively. Okay, so now if I say step over, exactly how I predicted, so no precondition violation. And now for valid combination over here, I can also choose to actually copy the long expression over here. Okay, you gotta be careful, you gotta copy the whole thing, right? Control C, and now if I paste it to expression over here, false. So that means, so this will help me predict this is going to be the precondition that's going to be violated, and I already evaluated beforehand it's going to be false. So now, as soon as I say step over, execute one step at a time, I'm gonna get precondition violation, right? Now you can see the stack trace directly, okay? So I just took a little bit extra time to actually explain to you how you can set the breakpoints around the point that you believe something goes wrong. So you can step into that particular problematic routine and see how exactly the contract violation or any implementation error occur. So please pick it up from here, and then you can apply that to your development to find your defects. Okay, let me stop here. So we already know very well how the precondition actually occurred. So what we like to do is we want to really write another kind of test in which if we expect a particular violation with a tag should occur, then it should be considered not as a failure, at least for the test, right? So whenever you say run, the precondition will still be there. That's not a problem, okay? However, when you say run workbench system, that particular precondition violation, if that's expected, it should be considered as part of the green bar, not as a red bar, okay? So now what we want to do, what I want to do is this one here, I want to take it out, but I want to leave that just as a comments, so you can still see this later for study. Select the whole block over here. Okay, let me just maximize it. So if you select the whole block, let me do it again. Select the whole block over here, Control K to put the whole test query into comments over here. Okay, and then I will simply just take this out. I'll just take it out. Okay, and then I'll put a comment here. Comment it out because we need a violation test instead. Okay, the way you create a violation test, the way you add the violation test will be very similar. You're gonna add it over here, but I'm gonna do that. Okay, let's go for because it's a very different category of test cases. So now I'm gonna just create another feature tag, right? You can see over here in the feature we got one called tests. So why don't I rename that feature section to be, let's say, Boolean tests. All the test queries under here should be Boolean queries. So now let me create another section over here for feature. So let me say call that violation tests. Each violation test is going to be a command rather than query, rather than Boolean query. That's something you want to pay attention to. Okay, so now each one of them will be a command. So now let me say this. So T test, let's say precondition of the make, birthday make. How about this? I'm making more precise. Birthday make. I want to make sure I test the precondition. I will give some invalid input so that the corresponding precondition should be violated as expected. Okay. So now I will do. It's going to be a command, so it has no return type. Notice that. Okay. And then I will say local over here. I still got BD birthday over here, and don't forget to put the comments over here. And then I would say let me copy this particular command and also paste it over here, and then test that the so let me use the same illegal output, right? The illegal input values. So I'm really expecting this particular precondition to be violated. Let me copy its tag. Okay, I'll just put it as a comment. Test that the precondition with tag valid combination is violated as expected on this particular invalid input values. So what I will do is I'm just going to use the one I did before. Can I just use this over here? Okay, and then I'll put it here. Before I run it, let me just write some comments for you. So just to note why we are doing this. Since we are expecting a violation to occur. So violation in general can either be a violation for precondition, of postcondition, or of class invariance. A violation to occur, you only have to write lines of code that will lead to that particular violation. Which means I don't really have to write another line to say, oh, by the way, if you say result over here is assigned to, for example, bd.month is equal to 11, for example, if you do that, it's not going to compile. Let's see why. Okay, it's a common mistake as well. If I simply say compile over here, it's a compilation error. It says that illegal use of result. Hopefully that's already quite obvious what the issue is. You can read the error message over here. It's complaining that result is only a reserved keyword for query only. However, this is a command, so it doesn't have the result, so you cannot use the result. Okay, hopefully you wouldn't run into that mistake. So let me just get rid of it. So this is this line here would be enough to actually trigger that particular precondition. That's what we want to have. Okay, and now let me again. Okay, let me just make sure everything still compiles. And now, in order to really add this particular violation test into the test execution, I need to add something like an add Boolean case, but we're going to add another thing. Okay, so let me just copy the tag name precisely. Okay, if you want to spell it out manually, that's okay, but make sure you make no typo, not even a single character. Let me go back to the beginning of the class over here, especially under the make. Let me also make some comments over here for you. So these are what we have done. So these are the Boolean tests. That's what we have done so far. And then we have to have another section over here just to separate them. So these will be violation tests. Okay, so now rather than add Boolean case, there will be one option for you. Okay, let me find it for you. It's called add violation. Okay, if you want to do code completion and control space, add violation case. Okay, you want to choose the second one. It's called add violation case with tag. We're expecting a particular violation. It is not the case that any violation would be okay. No, not really. If you actually, for example, if you got an array index out of bound violation, would that be okay? No. So you want to have just this particular violation with this tag. If some violation occur, but the tag name doesn't match the one I'm specifying over here, it is still considered as a failure. Okay, that's the essence for this particular category of tests. And then you can see over here is a procedure. Don't worry too much. Procedure simply means a command rather than function. Okay? So agents, don't forget to put agents. So now we're going to say T precondition birthday make. Right? Notice one thing. Okay, whenever you say add Boolean case over here, the name of the feature you put over here should be a query, a Boolean query, the routine. And then whenever you say add violation case with tag to test some expected violation that's being triggered, in that case, whatever name you mentioned here, that should be a command without any return value. Okay. Okay, let's just make sure everything actually is okay. Okay. Before I actually turn into run workbench system, let's just make sure the precondition should still be there because it should still be triggered. If I simply say run over here, right, it's more for debugging and close examination purpose. You can see now we are still violating this particular precondition over here, right? It's still there. You can see the stack trace confirm that. Okay, this is good. However, this is only to examine what actually happened. But this precondition, as we know, successfully forbids the illegal values to be passed in to create the birthday object. So from the testing point of view, it should be considered as a success because the precondition is triggered as expected. So what we will do is we're going to run over here. Previously, when we did the Boolean test case for this particular check, it will give us a red bar because the Boolean test case will still consider any violation even though expected to be a failure. But now since we do violation test case, if we say run workbench system, good. So now it is green bar. Okay. But now there's something you want to pay a little bit of attention to. Somehow, okay, it's a pass because we are expecting some violation with this particular tag to occur, and it did occur. So that's why it's a success. And then the star over here simply tells you it's actually a violation test command. Okay. Hopefully that makes sense to you. So when you do test-driven developments, so there are two kinds of test cases you can write. Either you write a Boolean test queries, or you write a test command where you are expecting certain violation to occur. Okay. Hopefully that's okay for you. And to really try to review these two different test cases and think about why. The main thing for you to think about before moving on to the next video is why this initial Boolean test query that we wrote is actually not satisfactory. Well, could be because it's causing a red bar. And then why we actually need this particular test command to do violation test with tag. Okay, review it before you move on to the next video.